Good morning and welcome to this session of virtual classroom project. Today we will be discussing elements of faults in this web initiative of Department of Geology, Government VYT PG Autonomous College Durg. This is Dr. S.D. Deshmukh from Department of Geology, Government VYT PG Autonomous College Durg. As we all know, structural geology is the branch of geology which deals with the various aspects of structures which are generated from the bending and breaking of lithosphere during the plate tectonics. These visible structures, they provide the record of stress and physical conditions in the earth during the geological history of the earth. There are various geological structures which we study, and they are important for understanding the location of earthquakes, the formation of mountains, as well as the finding or determination of location of mineral deposits. Before starting regarding the elements of faults, before studying the elements of faults, let us have some background information. Let us revise few concepts of rock deformation. As we all know that stress causes a material to change its shape and volume, and this is called deformation. A rock's response to stress, it depends on the rock type, the surrounding temperature and the pressure conditions, as well as the length of the time the rock is under stress and the type of stress. So these are the various factors which govern the deformation. Stress can happen without strain, but strain cannot happen without stress. Stress, as we all know, is the force per unit area, and stress is the change in shape or the volume in response to the stress. So we can say that stress is the cause and strain is the effect. So a horizontal bedding can be modified as a result of brittle deformation in terms of a geological structure which we call fault, and as a result of plastic deformation into a geological structure which we call folds. There are two basic types of deformation. One is called elastic deformation and another is called ductile deformation. So these two are the basic categories of deformation, and we all can understand these basic categories of deformation. We can study them with the help of these stress and strain diagrams. These diagrams, they tell us about the change in the material with response to the applied stress. So with the fundamental understanding of the Hooke's law, what we find is stress, as we go on increasing the stress, strain also increases. So this is the fundamental law which is called Hooke's law. And within elastic limit, the strain is directly proportional to the stress applied. After the elastic limit, the strain is irreversible. Within elastic limit, strain is reversible, and after the elastic limit, the strain is irreversible. And the material, it enters plastic region, that is, it shows ductile deformation where the strain is irreversible. At a certain point, the material breaks, and this point is called the fracture point. We can divide the materials into two categories depending upon the behavior of these materials. Materials having a small or large region of elastic behavior, but only a small region of ductile behavior before they fracture, they are called brittle materials. And the ductile materials have small regions of elastic behavior and a large region of ductile behavior before they fracture. We know very well regarding the three types of stress: compressive stress, tensional stress, and shear stress. In the case of compressive stress, forces squeeze or push towards one another from the opposite directions, as we can see over here in the diagram. In the case of tensional stress, the forces pull away from one another in opposite directions, and the result is stretching or extension, as we can see over here in the diagram. And the shear stress, in this case, the forces are offset from one another and they operate parallel but in the opposite direction. They operate in parallel but in the opposite directions. Folding and faulting have a major influence on the way Earth looks, and mountains form and disappear over time, as well as large rift valleys and other features also form and disappear with passage of time. The brittle deformation near the Earth's surface gives rise to faults. A fault may be defined as a fracture along which blocks of rocks have been displaced relative to each other. This planar discontinuity, it originates by tectonic forces acting regionally. The slip is primarily due to the brittle deformation. These faults, they range in size from microscopic dimensions, that is less than 1 mm, to thousands of kilometers, which we can say they occur at a regional level. We can also define faults in other words, like a fracture along which blocks of rocks have been displaced with respect to each other. A fault is a surface or a zone in the earth across which there is some measurable slip or shear displacement which has developed. Faults are the fractures on which slip develops primarily by brittle deformation process. Now let us try to understand about the difference between fault zone and shear zone. Deformation in the fault zone, it is distributed along a set of closely spaced faults within a zone, whereas deformation in a shear zone is ductile, involving either plastic or flow mechanisms. A fault zone is a brittle structure in which loss of cohesion and slip occurs on several faults within a band of definable width, whereas shear zone occurs at depth without definable displacement on the surface. With this background information, now let us discuss the elements of fault, which comprise of fault plane, head of the fault, hanging wall and footwall, throw of the fault, strike of fault, dip of fault, heave and net slip of the fault. In this slide we can see a fault in a block diagram, and hanging wall and footwall are shown over there in this block diagram. If a fault plane is not a vertical plane, then the block of rock which lies above the fault plane is called hanging wall, and the block which lies below the fault plane is called footwall. In this diagram we can see fault plane, fault scarp and fault line along with the hanging wall as well as footwall. So the fault plane is basically a surface or a plane along which the relative movement has taken place, while fault scarp is that part of fault plane which is exposed over the surface, and fault line is the line of intersection of the fault with the surface of the earth or any other plane of reference. When we observe the fault in a cross section, we can see the fault plane like what we see in this diagram, and there are few terms which we should know regarding the fault. One is head of the fault. The head of the fault is nothing but the angle made by fault plane with the imaginary vertical plane, and strike of the fault is the direction of its continuity on the ground surface, or the trend of the line which is formed by the intersection of fault plane with a horizontal plane. This we will see in another diagram. Dip of the fault, or the angle of dip of fault plane, is what we see over here as the angle made by the fault plane with the imaginary horizontal plane. There are two components of the displacement of a fault plane. One is called throw, another is called heave. So heave is the horizontal component of the displacement of the fault plane, whereas throw is the vertical component of the displacement of the fault plane. In this diagram we can see there are 3 or 4 terms which we should know about the faults. One is called net slip. So this net slip is nothing but the total amount of motion measured parallel to the direction of the motion along the fault plane, and slip describes the movement parallel to the fault plane. The slip measured along the dip of the fault plane is called dip slip, whereas the slip which is measured along the strike of the fault plane is called strike slip. The rake is the angle measured from the horizontal to the direction of the net slip on the fault plane. We can see the angle rake over here as theta in this diagram. This is another beautiful diagram which is showing rake, net slip, dip slip, strike slip, vertical throw, horizontal throw and heave. So we can see that the rake is the angle made by the slip direction with the hanging wall side. Rake is the slip direction of the hanging wall block measured on the fault plane from the dip vector. Rest of the terms we have discussed in the last slide. This slide beautifully shows regarding the relationship of throw and heave with the fault plane. You can see over here, throw is the vertical displacement component and heave is the horizontal displacement component along the fault plane. This is another beautiful block diagram which illustrates various elements of fault. We can see the upthrown block and the downthrown block over here. We can see a marker bed which has been displaced due to this fault. We can also observe the angle of dip or the dip of the fault plane as well as fault scarp. Here the arrows, they indicate the direction of relative displacement over here, and we can also see the fault line very clearly. It is the line of intersection of the fault plane with an imaginary horizontal plane. So these are the elements of faults which we should remember, which we should learn about. And with this background, we will discuss classification of faults in our next class, in our next interaction, next session. So these are the references. So thank you all. Thank you so much for watching this video.